Hello students. In this video we'll see how to solve a constant coefficient ODE where there's an irreducible quadratic factor. So let's consider the following constant coefficient ODE. I'll write it in D form. D cubed plus 9d squared plus 16d minus 26 applied to y is equal to 0. So we see that we have integer coefficients, so we can write down the possible rational roots. The possible rational roots are the factors plus or minus the factors of 26 over the factors of 1. So we just have to find the factors of 26. So we'll have plus minus 1, plus minus 2. Then what are the other factors of 26? and 26. So now let's test each of these numbers. So we'll test 1. So we'll do synthetic division. I have 1, and then I'll put a 1, a 9, a 16, a negative 26. Bring the 1 down. 1 times 1 is 1. I'll have a 10. I'll have a 10, a 26, and a negative 26, and I'll get 0 over here. So we see that 1 is in fact a root of this equation. So we can take our constant coefficient ODE and write it as d minus 1, and then d squared plus 10d plus 26 applied to y is equal to 0. Now on this term I see that it's irreducible, so I'll complete this square. It's d minus 1 and then d squared plus 10d. Then I'm going to add half of 10 squared. So I will add in 25. And then since I added in 25, I'll have to subtract off 25. So plus 26 and then minus 25. Applied to y is equal to 0. So in this step I've completed the square. So rewriting this, I will have a d minus 1 and then a d. The first 3 terms are now a perfect square. They are d plus 5 quantity squared plus 1 applied to y is equal to 0. Now we recall the following operator. Recall that d minus a squared plus b squared applied to y equals 0 has the following trigonometric functions times exponentials as the solution. The solution to this will be y equals e to the ax and then c1 cosine of bx plus c2 sine of bx. So we will apply this general formula to this factor over here. So over here what we will have is we're going to have that a is equal to negative 5 and b is equal to 1. So I can use that information in this equation to write down the general solution of our problem. So we will see that our solution will be y is equal to c1, and then I have an e to the x for my first d minus 1 term. Then I'll have a c2 e to the negative 5x cosine of x plus c3 e to negative 5x sine of x. And that is the general solution of our differential equation, because we can check that these functions, this exponential e to the x and these 2 functions over here, these 3 functions can be seen to be linearly independent. And we can apply our main theorem that says if I have 3 linearly independent solutions to a third order constant coefficient ODE, a linear combination of them will be the general solution. Thank you very much.